Dart School presents Midpoint theorem. The midpoint theorem tells us that the straight line joining the midpoints of two sides in a triangle is parallel to the third side and equal to half the length of the third side. Let's try and figure out what that means. So we have a triangle here. And if you pick up the midpoints of any of the two sides, let's say this one and this one, and if you join these two midpoints with another straight line, this straight line is A, parallel to the third straight line, the third side on the triangle, and B, the length of this line is equal to half the length of this side in the triangle. So let's just name this triangle as A, B, and C. And then let's also say that D is the midpoint of AB, so that AD is the same length as DB, and let's also say that E is the midpoint of AC, which means AE is the same length as EC. To prove that the statement out here is correct, the first thing we do is draw a straight line that's parallel to that AB side in the triangle. And let's extend this DE to meet that straight line at another point, and let's call this point F. We don't need this portion of the straight line beyond F, so I'm just going to go ahead and erase it off. Now, if you look at the two triangles ADE and ECF, this angle is the same measure as this angle because they're vertical angles. As this line and this line out here are parallel, that means that this can act as a transversal. This angle out here, angle A, is the same measure as this small little angle, angle ECF. They are the alternate interior angles. Now we have two angles of this triangle equal to two angles of this triangle, and also because E is the midpoint of AC, AE is the same length as EC. Therefore, the two triangles out here are congruent. Angle, side. And that leads us to conclude that the length of CF is exactly the same as the length of AD. Therefore, this is the same length. But AD, D being the midpoint of AB, is the same length as BD or DB. So, this BD and this CF or FC, they are not only parallel. Remember, I drew CF to be parallel to this side. So by definition they are parallel, and now we have gone on to show that they are the same length. So the opposite sides of this quadrilateral that you see over here, BCFD, one pair of the opposite sides are equal in length and parallel. Therefore, BCFD is a parallelogram. Now I just proved that one pair of the sides on the quadrilateral are equal in length and parallel. What about the opposite sides? What about DF and BC? Now, if you think about a quadrilateral that has got two sides the same length and also parallel, and if you draw the other two sides, they have to be the same length and parallel. If you wanted to make them, let's say, intersecting or non-parallel, so they would probably go like this, so that they would intersect at some point, and that would mean these two sides are not the same length. So this would go beyond this point. Right? So in a quadrilateral, if we can show that just one pair of sides are parallel and the same length, the quadrilateral has to be a parallelogram. So there you go. We just proved that DFCB is a parallelogram, which means that DF is parallel to BC and DF is nothing but an extension of DE. Therefore, it goes on to prove that DE is parallel to BC, which is the third side in the triangle. One part is done. It's parallel to the third side, proved. Let's talk about the length. Now, if you come back to the two congruent triangles, ADE and CFE, the length of DE, this one, is going to be the same length as EF because the two triangles are congruent. The length of the corresponding sides are equal. Now once we have that, and if you look at DF, what is DF? DF is the same length as BC because they're the opposite sides on a parallelogram. So the moment we know that DF is the same length as BC and E is the midpoint of DF, so let's say BC is a X, so all of this is a X, and E being the midpoint cuts DF into two equal pieces, and DF, all of that is the same as BC, which is X. Therefore, this part is going to be half of that, X over 2, and this part is going to be half of that, X over 2. So DE, which is the line joining the midpoints of AB and AC in the triangle, is exactly half in length of the third side BC. So the second part has been proved as well. Let's look at a simple problem related to the midpoint theorem. So we have a triangle ABC. It's given that the length of the line segment AD, A to D, is the same length as DB, D to B. That means D is the midpoint of AB. So this is the same length as this. In the same way, AE is the same length as EC, which means E is the midpoint of AC. So this length is the same length as this length. Therefore, DE is necessarily the straight line joining the midpoints of the two sides in this triangle. And you would expect that to be parallel to the third side and have the length of the third side BC. It's also given that angle DAE is 40 degrees. DAE, so this angle out here is a 40 degrees. Angle DEA is 10 degrees. DEA, this angle is a 10 degrees. It doesn't look like a 10, but never mind. We are just concerned about the numbers. And we need to find angle ABC. ABC, so this is the angle that we need to find out. To be able to do that, the first thing we note is we can easily find the measure of angle ADE, this angle out here, by subtracting 40 and 10 from 180, because in this triangle ADE, the three angles add up to 180. So if you take away a 40 from 180, that becomes 140 and another 10. So this angle out here is a 130 degrees. Now how is that going to help? The midpoint theorem tells us that because DE is the straight line joining the two midpoints of the two sides of the triangle, it's parallel to the third side. And therefore, angle ADE is the same measure as angle ABC because they are the corresponding angles. If you consider DB or AB as the transversal, the two angles are congruent, which means this angle out here has to be 130 degrees.